Welcome to VW 1.6. We're going to quickly summarize what we went over in class. We're going to let R and S be the two roots, or the solutions, of ax squared plus bx plus c equals 0. So R and S are just common letters we're going to use. This is what we worked on in class. Here's our standard quadratic equation. So in class we proved that if you add the roots, r plus s, you get negative b over a. And when you multiply them, r times s, you get c over a. So in this video, we're going to work on how to use those things and what they're called. So you want to highlight this. They're called Vieta's formulas. And they're very, very handy. And in pre-calc honors, you're going to use them even more extensively. But I just want to show you kind of the beginning of how these formulas are used. And on the SAT, you will actually see questions like this as well. So first one is find the sum and product of the roots of each of the following equations. So if you didn't know this, you'd have to actually solve it and then add them and multiply them. But if we know Vieta's formulas, we can actually do it pretty quickly. The sum right here, let's do opposite b, so negative 13 over a. The sum is 13. Done. The product, that's going to be your c over a. That's 36 over 1, and that's going to be 36. Now for b, for this equation, we want to manipulate it a little bit first. We want there to be a 0. So let's write 0 equals 2006x squared plus 2007x plus 1977. The sum, that's opposite b over a, so negative 2007 over 2006. And the product, that's c over a, so 1977 over 2006. So for a question like this, we could easily factor it and find these answers, but notice how this, right, to do the quadratic formula, complete the square, and get these numbers manually would be very hard. That's why Vieta's formulas are really powerful, just negative b over a and c over a. I'm going to show you one more cool application of it here. It says let p of x equal 2x squared plus 7x plus c. It gives you your roots r1 and r2. Let's just find this expression. All right, so 1 over r1, 1 over r2. So again, what some people would try to do is they're going to try to actually find the two roots, take the reciprocal and add them. That'd be pretty tough. So what we're going to do is actually work with the expression. If I get the common denominator, notice how that would be r1 times r2. And if you add the numerators together, you get r2 plus r1. And that's because for common denominator, you'd multiply this by r2, this one by r1. Which means this expression is equal to this thing. And this thing should look familiar. This top part, that is simply the sum of the roots. That's negative b over a. So let's do that. That would be negative 7 over 2. This bottom part is the product. So that's going to be c over 2. Let's reduce that. Negative 7 over c is our answer. And we're done. Here's our last part of the video. We're going to talk about how to create quadratic equations. So I have a technique called reverse complete the square we're going to talk about. And also we'll talk about kind of the standard method. So first for A, I'll show you the standard method. The standard method is simply going to be x minus the root, and that's a sub 1, and x minus your other root, and make that equal to 0. That's going to be like the standard way, and it's really easy to do if the numbers are pretty easy to work with. So for this one, we could really just write x minus 1/2, x plus 1/3 equal to 0, because notice how that is a quadratic equation with the specified roots in it. That would work. The issue with this, however, is that it says a, b, and c are integers. So to do that, just kind of play with numbers a little bit. Let's multiply this whole thing by 2. You get 2x minus 1 multiply this whole thing by 3, and you get 3x plus 1, and that equals 0. And now when we multiply it out, it's going to be what we want. There are no fractions anywhere. So we multiply, that's 6x squared minus x minus 1, that equals 0. Now the standard method is great, but if we have something like this, notice how it's much more complicated. To do this would be pretty challenging. So then we have another method, and I call it reverse complete the square. Because what we're going to do is just simply complete the square, but in reverse. So you're going to write x equals 2 plus or minus root 3 over 2. That's your solution. And we're going to go backwards. We're going to make the equation from the solution. So move the 2 back. So 2x is equal to 2 plus or minus root 3. We're going to subtract this 2 back to this side. 2x minus 2 equals plus or minus root 3. Now here's a cool part. We're going to square this. Because if I square that, if I square a plus minus root 3, no matter what, it becomes positive 3. And the left side, that's going to become 4x squared minus 8x plus 4. And look at that. We recreated the equation. So now it's 4x squared minus 8x plus 1 equals 0. And that is going to be the equation that generated this solution. Okay, so work on the rest of the questions and bring whatever questions you have to class.